All right, we are on practice test number 2.
I'm actually doing this too.
And we are ready for problem number 3. Okay, I'll say that one more time. We all have our practice tests out, and we're ready for problem number 3. Here we go. How many triangles are possible? Okay. How many triangles are possible? All right, so the first thing I'm going to do is draw a picture of what I've been given. Now, when I figure out how many triangles are possible, remember, the answers could be 0, 1, or 2. So I'm going to figure out if there are any triangles possible, and if there are, if it's just one or if that second one will actually work. So, here we go. You want to pick that up, Luke?
Yeah, I want to.
In order to set this up, I'm going to do the law of sines. So what's the law of sines going to say for this problem? Sine 73 over 6 sine s over 9. That's exactly right. So now I'm going to cross multiply. So I'm going to figure out that sine s is 9 sine 73 over 6. I'm just cross multiplying and dividing in my law of sines equation. Now, when I type this in, 9 sine 73 divided by 6, I get a decimal, right? The decimal is not the answer. How do I actually find the angle? Second sine it. Yes, indeed. So I second sine. Oh my. What happened? I got an error. And when I get an error message, that tells me that there are no triangles. Remember, when it says how many triangles are possible, there could be 2, there could be 1, or there could be none. This is an example of none. How do you know none? When you type it in on your calculator, it gives you an error. That means none. All right, so now we're ready for problem 2, which, by the way, we will set up exactly the same way. The numbers are different, but the setup is identical. So once again, we'll use our law of sines. So sine 52 over 16 equals sine s over 18. Do our cross multiply and all that. And we end up with what we're going to type into our calculator. Okay, make sure you can get that. Cross multiply. This is my law of sines. Cross multiply. Then
we get that answer for after you multiply all that. How far do you round it?
I'd say 100 if the answers don't say. Now, wait a minute. What are you talking about? Are you talking about the actual angle, or are you talking about that decimal?
I guess we get out.
Okay, you don't want to round that decimal off,
Alright.
because you need an answer from that, so you're going to need all those decimal places. Okay, so there's an easy way to do that on the calculator. You don't have to retype that number back in. You just, once you get that decimal, you just type second sine, second answer, and the answer is the negative sign down there. So second sine, second answer. And then press equals, and it will give you the angle, and you don't have to retype it in. So it's 62.44. And there's no round off error in there. Thank you for doing that.
I got 62.87.
I got 62.8.
I didn't do the second one, but I did .9.
Okay, you rounded off, and I just got done telling him, don't round that off.
Okay.
You're gonna get points off every time you do it. Now, not a lot of points, but you're gonna miss points. So do the second answer, or retype in the whole decimal, okay? Now, we got an answer this time. We did not get an answer to the first problem. We had no solution. If there is another answer, and sometimes there is, so we have to check it. If there is another answer, what will that other answer be? This was the first one you got. If there's another one, what will it be? 180 minus that. Oh shoot, somehow I ended up. 180 minus that, always 180 minus it, and it's 117.56. All right. Now, what do I do to see if there's two answers or one? Is it okay to have a 52 and a 117?
Yeah.
Is that okay?
Yes.
So this problem has two answers. Both the 62 and the 117 are good. What's the matter, Ethan?
Why did you put 170?
If there is a second answer, and that's the whole point of doing the problem, how many triangles are possible? If there is a second answer, it is 180 minus the first one. So the first angle S I got was 62. If there's another angle S, it's 180 minus the first one. Every time, 180 minus the first one I got.
You got the 62 you signed.
What then?
Tell me what you just said. So you said 180 minus 62.1, and then there's a second one, the same thing.
No. That is how you get the second one. 180 minus the first one is how you get the second
So
one.
there's two triangles.
So there's two triangles possible.
What's significant about that first sign? What does that give you? What information is that? Not the one on the left.
What do you mean, what's significant about it? This one is not a triangle. You can't make a triangle out of this.
That's a different problem.
This is problem number one. This is a different problem. Yes. Now, hurry up. Now we are on problem C. All right, so here we go on problem C. All right, it looks just like the other ones. The directions are the same. The setup will be exactly the same. Sine 75 over 10 equals sine S over H. So sine S is 8 sine 75 over 10. So then I go to my calculator. And when you type that in, just like happens in all these problems that say how many triangles, when you type it in, you get a decimal, right? So what do we need to do to that decimal? Second sign it. And this time I got 50.6. Okay. I got an answer. Now I need to check if there is a second answer. If there is a second angle S, there's one angle S, my calculator just gave it to me. If there is a second one, it will be 180 minus that, right? So 129.4. Now notice I keep saying if, because sometimes the second triangle doesn't work. How about this time? Can you have a 75 and 130 basically? No. So the second answer, if there is one, is 129. 129 doesn't work, so therefore there isn't a second answer, and there is only one triangle. If the second triangle works, then there's two. All right, so that's that kind of problem. All right, so now we're going to the other way. Find the area. All right, so now we're switching gears. This is a different problem. This is a different problem. We are finding the area. Okay? Now, to find the area of the triangle, there are two things we would love to have. All right? To find area, we would like to have all three sides. Because if we have all three sides, we can use what special area formula? Heroes. That's the one that has the big radical in it, right? Or we either want all three sides, or we want two sides and the included angle. So in other words, we want a situation where we have this side, and that angle. Those are the two situations. When it says area, that's what you want. All right, so let's look at the first area problem. 4A. What do I have? All three sides. So if I have all three sides, then my area is going to be this big square root. And it's going to be the square root of what? It's going to be the square root of S, S minus A, S minus B, S minus C. What does S stand for? Semi-perimeter, which is half the perimeter. All right, so let's look at our triangle here. What's the perimeter? Perimeter is 18. So the semi-perimeter will be 9. So I'm going to have the square root of 9. Now, what kids often do, because they're not paying attention, is they'll put 5, 6, and 7 in here. That is not what goes in there. The numbers that go in there are not the sides. The numbers that go in there are the semi-perimeter minus the sides. So 9 minus 7, 9 minus 5, 9 minus 6. And then you just type it all in and take the square root. So we have 9, 9 times 2 times 4 times 3. Square rooted. I got 14.7 basically. Did you for the area? Okay, so when they say area, we love it if we have all three sides. That's how we handle it. Easy, easy, easy. All right, let's look at problem 2, because I bet we don't have all three sides. We don't. In fact, problem 2 is the hard one. Because not only do we not have all three sides, we also don't have two sides in the included angle. I have one side, I have some angles, but if I want to do the area, I need another side. What am I going to have to do? Well, I could find that angle for sure. What would that be? 45. Is everybody okay with that? We could find that angle easily enough. Remember, triangle angles always add up to 180. I still don't have enough sides though, kids. If I knew this side, I could say 1/2 side, side, sine. I need 2 sides and the included angle.
Sine 45
Oh, what?
as cosine.
Can I, let's just say I want this side. Can I find that side?
Yes.
Yes, I can. Using the law of sines. So sine 45 over 15 equals sine 72 over S. Now, why am I doing this? Because when I want area, I either have to have all 3 sides, or I have to have 2 sides and the angle in between them. I do not have enough sides in this triangle to find the area. So I'm working on getting another side. I'm either going to do law of sines or law of cosines. I have a pair right here. That means I do the law of sines. So I'll cross multiply. And I'll divide.
Where?
Okay, now take a look at it. Take a look at it. What do you think? Is that okay? Now I'm going to type that in on my calculator. It would be awesome if everybody would bring a calculator tomorrow so that you could practice. There's so much typing to do in this, and I'm afraid come test day, some of you aren't going to know what to do because you've not practiced. I got 20.17. What is that? S? Now, true or false? That's the answer to the question.
False.
False. Our job is to find the area. Do I now have good information to find the area? Yes, because I have a formula that says area is 1/2 side times sine of included angle. So here we go. 1/2 side 20.17 and 15. Those are my 2 sides. And since I'm using 20.17 and 15, the angle I have to use is 63. It's the one in between them. So sine 63. Type it in. That's the area of the triangle. Mrs. Hollis is fired up about something. Did you get 134.79? Everybody okay? Now that one was hard because we didn't have what we needed. So we had all this first step to get that side so we could then find our area. Look at the last one, look at C. Can you find the area of problem C? It's a no-brainer. Look at the given, kids. Don't you have 2 sides and the angle in between them? That's what you want. So the area is 1/2 what? 1/2 11 times 10 times sine 53. No work, no anything, just type it in and you have your answer. That's what we love. 43.92. Why was that one so much easier than this one? Because we had what we needed, right? We had 2 sides and the angle in between. Here we didn't, so we had to fight for it. Okay, one more page and you're done with this one. Here we go. All right, these are the ones where we have to draw a picture. Okay, so we're going to draw a picture of a regular pentagon inscribed in a circle. A regular pentagon inscribed in a circle with a radius of 10 feet. All right, so here's what I want you to do. If you're not sure, I want you to draw yourselves a circle. Now, what does pentagon mean? 5. So I want you to put 5 marks on this circle, kind of spread them out so they're even as you can make them. Don't worry about being perfect. And then I want you to connect those marks. And there's your pentagon inscribed in a circle. Now the word regular means all the sides and angles are the same. So I don't have a very good picture here, so you just got to pretend all the sides are the same length. Okay? And we know that the radius, that would be this, that's the radius, is 10. So there's your picture. Everybody got it? Now, you need to find the area of that picture. So we did this yesterday, or someday. What's Sunday? Who remembers? Well, wait, first, I need to put in some more triangles here. So first, I'm gonna add in all the spokes of the wheel. And how long are all those spokes? They're all 10. Everything's 10. Now, see these 5 triangles here? They're all the same size. So if I could find the area of that one and multiply it by 5, I'd have the answer. Agreed? Okay, so how do I find the area of a triangle? What are the 2 things I wish I had? All 3 sides, or 2 sides and the angle in the middle. Now right now I don't have anything. I don't have either one of those. But wouldn't it be cool if I could find that angle? Paul? 360 divided by 5. That angle is 72. You guys do not need to be geniuses to know that. I mean, Paul's a genius, but you don't need to be a genius to know that. All you need to do is pay attention. You got 360 degrees in a circle. It's split up into 5 equal pieces. So each piece is going to be a fifth of 360, 72. Now, what's the area of that triangle? 1/2. Side times side times sine. One half side sine. So we can type that in on our calculator. And here is a place where we make mistakes sometimes. Did you get 47.55? Now, don't write that down though, because what is that? That's the area of this triangle. Times it by 5, because you want the area of the whole shebang. So 237.76, is that inches? Feet, square feet. So the area of that thing is 237.76 square feet. Now, skip down to the last question on the page. Does it look familiar? It is exactly the same. So let's see if you can do that one. See if you can draw the picture. So how do we start?
So it's like,
The what?
how many years is that together?
Decade? 10.
It was like decade.
Yeah, but this isn't a dodecagon.
Like that's 12, right?
Yep. All right. So Phil, we're on the last problem. We're going to draw our own picture. Would you draw it, please, on your paper? You can do it. I promise. It would help if you were on the right page. All right, so what have you done? Luke, what have you drawn? Now we're on the last problem now. We're all down here on the bottom problem. You do all that other stuff now. You should actually draw the decagon. So we're going to draw a circle. And then we're going to make 10 marks around it, right? Alright, so I didn't do a very good job here spreading those out, but there we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my decagon. Inside a circle with a radius of 15. Alright, everybody got it drawn? What's the next step? I see some of you busily working. You're already moving on, which is awesome. Make all the triangles. And all those lines I'm drawing right now are 15s. So I'm going to focus my energy on one of those triangles. How many of those triangles are there? 10. And I'm going to focus on one of them. In order to find the area of that triangle, I need to know that angle. Oh, it's not 18.
It's 36. It's 36.
Oh, it's 360.
Yes, it's a revolution. So 36 degrees is that angle?
Yeah.
So my area of my triangle would be what? 1/2. 15 times 15 times sine 36.
66.1.
So I can type all that in and then be very careful.
661.
That's not the answer. What do I need to do with that? Times it by what? 10. 661.26 square inches. All right, Tony, what do you think? You got that? All right, now let's go back up to number 2. We've done the top and the bottom. Let's do the middle 2 now. Find the area of a parallelogram. All right, so here's a parallelogram. Shh, Marissa. One phrase at a time. You have a parallelogram. The sides, Luke, turn around. The sides are 10 and 16. Now, in a parallelogram, that also means this is 16 and this is 10. So feel free to mark those if you wanted to. Opposite sides are congruent. The larger angle is 104. So eyeball it. Clearly, you got this angle and you got this angle. This is the larger one. Find the area. So Ellie says, I'm going to make a triangle. And that's a really nice triangle. Because look what you have right here. Don't you have two sides and the angle in between?
1/2.
So what's the area of that triangle? 1/2 10 times 16 times sine 104. Is that what you're putting in the answer line? No, because you gotta times it by 2. Because what is this? That's the area of this right here, right? We need to double it to get the area of the whole figure. So the area of the parallelogram will be 155.25 square inches. Or centimeters, sorry, square centimeters. Now, anybody have a question about that? Okay, now, the diagonal that I drew there, the parallelogram has two diagonals, right? One of them's long, one of them's short. Which one did I draw? The long one. So I'm gonna redraw my picture because question number 3 uses the same parallelogram, but I want the other diagonal. So here's my parallelogram, but I want this diagonal. And I'm finding the length of it. Now, are we going to be doing 1/2 side, side, sine? Why not? That's area. Does that question have anything to do with area? No. I'm going to be doing the law of sines or the law of cosines. It's definitely going to be a cosine law, but I need this angle right here, Ethan. What do I know about that angle? Alex? It's 180 minus 104. That's exactly right. These two angles right here, let me take this line out for a minute. These two angles right here always add up to 180. So if I know that that one is 104, this guy's got to be 76. Now somebody said law of cosines, and that's exactly right, because I don't have a pair. I can't set up sine something over something. I don't have that. So what's the law of cosines going to say? X squared equals. Here we go. Are you good at this? Let's see. 10 squared, good. 10 squared plus 16 squared minus 2 times 10 and 16. And it's not sine, it would be cosine 76. Did you get 278? Here's where we make another big mistake. The answer's not 278, is it? What do I need to do? Square root that. Do not forget. When you use the law of cosines, kids, that's x squared. So the actual answer to the question is 16.69 centimeters. 16.69 centimeters. Good job. All right, that practice test is done. So we are going to do another one. But first, I think I'll let you go to lunch. Isn't this a lunch period? All right, you're just going to stay here and do it. I need your attitude. All right, so I need you back here at 12. 12:25. In your seats at 12:25. 12:25. Ellie, would you get that off?
Yeah.
12:25.